Hi, today we are going to look upper bound algorithm in binary search. Okay, in previous example, we solved a lower bound problem, and in that, if we see, let me just show you that particular line. Yeah, just a second. Yeah, here this was lower bound algorithm, right? And here we used L is less than R, and we took R to the boundary, not not to the, let's say, length of the array is 0 to 2, so we are not going to consider R to be at 2. Initially we'll be considering at 3, then that algorithm will be working. Now your question will be, why we are considering left to 0 and right to uh, the length of the array, means there is no element here, so I wrote X here. Okay, so why R is not 3, why R is 4? Because if you see any lower bound algorithm or upper bound algorithm, your answer can go beyond this range, right? Means let's say you are searching for element which is let's say 11, then that will not be present in this array, right? Means the next element which is greater or equal to 11 will be at fourth index, so our fourth index can be answer. So what is the range of our answer? That is from zeroth index to fourth index, right? That's why we consider that a fourth index as well. The same concept we are going to apply for upper bound algorithm. It's just the case that in upper bound, let's say the same example is there and you wanted to search 10, then uh, we need the element which is greater than 10, not the 10, right? So if we look in this array, 10 is equal but not greater, so upper bound of 10 will be at fourth index, right? So that will be the answer. So what changes required in case of upper bound algorithm? Everything will be same, it's just this case. uh yeah, let me box it. This case will be greater than only, not equal to. Basically, we can directly code it, and I'll explain you. Okay, so what I was saying is that to solve upper bound question, right, means you need left pointer that will be starting from 0, right pointer that is len of nums. Why length? Because answer can be uh, means if the array size is 3, answer can be 4 as well, means that is the nth number if we start from 0. So that's why we are keeping right is equal to length of nums. Okay, while left is less than right, we need to continue this. We need to find mid is equal to left plus right by 2. You don't have to do this because in CPP, because that can go beyond range, right? Let's say you are using integer, then integer flow can be possible over there. So people use like left plus right minus left divided by 2, so that works fine. But in Python, left plus right divided by 2 will anyway able to handle, so that's why we wrote that line. Okay, now if what we need to do, if nums of mid is greater than x, right, then we need to move our right pointer to mid, else we just have to move left pointer to mid plus 1, means we will be skipping that value. Now what we need to return left, because wherever the left pointer will be, that will give us the exact index, upper bound index. Okay, so running that, I don't have premium of take you forward, but yeah, I can surely say that this algorithm will work fine. And its time complexity will be order of log n, because every time we are just calculating mid and dividing our search space into half, right? First time the search space was of size n, we found mid, we divided into two part, and now the search space is n by 2, right? And here this is sorted array, so that works fine. Means binary search, if we are using binary search, it doesn't mean that it needs to be sorted, but the thing is, if you or we can divide our search space into two half and decide whether which half we need to explore next, then that will fall into binary search category. And if you imply this rule, then most of the cases it will turn out to be a sorted array only. So yeah, that's why binary search is here. And I guess this is pretty much enough for upper bound algorithm. Yeah, thank you so much.